Okay, stats, we're on day 4. This is going to be just all of chapter 5. Binomial probability. It's just this first one page. We'll do day 5 tomorrow, chapter 6. So just one page today. I'm going to go through this top box here and use kind of an example, and then I'll let you do the rest on your own. So when we're talking about binomial probability distributions, binomial means we have to have it separated into like two outcomes. Okay, so even though you have, like, let's say you're rolling a dice or you're doing something that has more than two outcomes, you still can separate them out into just two outcomes by, like saying odd or even, like even though there's 6 sides to a dice, you can still make it into a binomial by separating it out into two groups. So like here, the data that you guys are going to be looking at is looking at who is born in spring and then who is not born in spring, okay? And spring is going to be March 21st through June 20th, okay? So you're going to look at this data here, and you're looking at the percentage of kids that were born in spring, okay? So maybe there's like 5 out of the 14 of you that were born in spring. I have no idea. Okay, figure that out and figure out what decimal that is, and that's going to be how you separate it. Okay, don't use 5 out of 14 because that's not probably correct. But you'll have to calculate that, right? How many people are born in spring? What percentage of students in your class? Okay, you want that as a percentage. Okay, so in my example up here, we're talking about if I have a tree, the probability of me killing the tree is 72%. Like, I cannot keep anything alive, so 72% is the chance I'm going to kill it. I just made that number up just for the sake of this example, okay? That means the probability of me not killing the tree is 28%. If I subtract that from 100, these should add up to be 100%, okay? Those two pieces of information is what I need in order to do this binomial. I have two things going on. Either I'm going to kill the tree or I'm not going to kill the tree. Either you're born in spring or you're not born in spring. Okay, those are my two outcomes. Okay, and then from there it just boils down to this formula that we're gonna talk through. Okay, so there are 3 pieces to this formula. We have NCX. Okay. I think when we actually did this chapter, we talked about the variable x, and instead of using x, they use r a lot of times. So if you want to use r, you can use r instead of x. I don't really care. But NCR, p to the r, q to the n minus r. We'll talk about what those things are. All right. So n is the total number of trials that you have. Okay. So in my example over here, we have the probability of me killing a tree is 72%. The probability of me not killing a tree is 28%. Now, using that information, if I plant 10 trees, that's where my n comes from, right? If I'm planting 10 trees, find the probability that exactly 5 of them live. This is going to be my x value, or my r value, if you like to call it r instead, okay? So 10 trees is the total. X or 5 is what I'm looking for, okay? So total number. And I'm going to call x the number that I'm choosing. Okay, so, and I'm going to call this r or x, okay? So the number that I'm choosing, so in this case, n was 10, and the number that I'm choosing is 5, okay? P is the probability of success, okay? And in this case, success means that I guess in this case, success means me killing a tree. So if we designate this as being my P, the probability of success is going to be kill trees, I guess. So it doesn't necessarily always have to mean success. Maybe it's like talking about like the chances of me getting a female baby versus a male baby, right? Success doesn't necessarily mean that it's a female or a male, whatever. It's just the probability of success and the probability of failure. So it's like whatever you're choosing versus not choosing, I guess, is maybe a better word for it, okay? So whatever I'm looking at as being my success and whatever I'm not looking at being as my failure. So if we're talking about killing trees, that's going to be my success, I guess, in this case. 0.28 is going to be Q, okay? Now, make sure that these go as the decimal form. So 0.72 and 0.28 is going to be your P and Q, okay? All right, now I'm going to answer this question right here, and then we'll see how this translates, all right? So if I kill, or if I have 10 trees total, all right, I'm going to do a little plot off to the side over here. If I have 10 trees total, okay, that means I'm going to say live or die. okay? If I have 10 trees total, then I could have all 10 of them live and none of them die. Or I could have 0 of them live and 10 of them die, right? Or I could have any one of these combinations, 8 and 2, 7 and 3. I, for some reason, can't think right now. 5 and 5, 4 and 6, 3 and 7, 2 and 8, 1 and 9. Okay, so I could have any one of those combinations happen, right? Like I could have this one where 6 trees live and 4 trees die, right? Out of the 10, right? And the chances of that happening are broken down into this formula right here, okay? So let's do just like the top one. Well, no, let's do the bottom one because the chances of the bottom one happening are pretty, a lot bigger, right? If I have a 72% chance of killing trees, then the chances of 0 of them living and all 10 of them dying might be like higher at least than this, right? Like if I have a 72% chance of killing a tree and all 10 of them living, that's probably not going to happen, right? So the way that I would calculate this guy was is I would do 10. Oh, let's see, 10C. Are we going to do live or die? Let's go ahead and go with dying. Okay, so 10C10 means all 10 of them are going to die, right? And then I take my percentages, which are my P and Q. So P here, Q is here, right? 70, I need to move this over. Let me move this. I don't have enough room. I want to move him down here. Okay, so 10C10, that's going to be my first piece, my first chunk, okay? And then I have P, which is 0.72, and I have Q, which is 0.28, right? Now I have to figure out what those exponents are, right? So 72% chance was the kill rate, right? And we're saying that all 10 of them are going to die. So I'm going to put 10 here, okay? If 28% was my live rate, then 0 of them are going to live there. So that's how I would break this down. So 10C10, I would take 0.72 to the 10th power, 0.28 to the 0 power, multiply those 3 together, and I would get that decimal number here, okay? Let's go up and do like this one, 3 and 7, right? This would be 10C, and then depending on which one you're going to do, we could do 10C7, right? If that's going to be my die rate, right? So 0.72 and then 0.28, right? 72% is the chances of them dying, so 7 of them are going to die. If 7 of them die, then there's 3 that are going to live, right? Okay, now, just FYI, 10C7 is going to be the same number as 10C3. So if you accidentally put it as 10C3 instead, just as long as you get these numbers in the right spot, I do want the 7 to go with the 72 and the 3 to go with the 28, okay? But just look and see which number is going where. But if you put this as 10C3 instead of 10C7, it's not going to screw anything up, okay? Because those will be exactly the same number. 10C7 is 120 and 10C3 is also 120. So that's what that guy is, okay, if you enter it into a calculator. Same thing with like this one. 10C6 is the same thing as 10C4. So it doesn't matter which number you put here, just as long as the 72 and the 28 are corresponding to the correct exponent, okay? All right, so what's the probability that exactly 5 of them live? I'm going to actually calculate this one out, okay? We would do 10C5. I want 5 to live, okay? So 0.72 and 0.28. This is my die rate, and this is my live rate, okay? So if I'm talking about exactly 5 of them living, that means I want 5 to go here. But if 5 go here, 5 have to go here because these two have to add up to be 10, right? So 5 are living, 5 are dying, and then I calculate this out and I get a number, okay? When I did this in my calculator, I got 0.084-ish, which is about 8.4% chance, okay? So this means that if I planted 10 trees, I would have about an 8% chance that exactly 5 of them would live, as opposed to 6 of them living, or 7 of them living, or 2 of them living, right? I have an 8% chance that exactly 5 are going to live and 5 are going to die, okay? And that would correspond to this row in the table. This would give me this percentage right here. This 5 and 5, that percentage, okay? So you're going to do this down below. We're going to fill the whole table out, okay? And number 30, FYI, I have a typo For some reason, it just didn't get moved down or something. You already know two of these values from 28 and 29, okay? 28 is asking for what is the probability that exactly 3 of them were born in spring? That goes right here. What's the probability that exactly 5 of them were born in spring? That number goes here, okay? So you're calculating what those are, okay? And these are the people born in spring, which means that if 0 of them are born in spring, no spring would be all 10 of them are born not in spring, if that makes sense. So you have spring babies versus no spring babies, okay? If you have 4 of them born in spring, that means 6 of them are not born in spring. Okay, like that's that combination there, okay? So binomial, you're filling out like this table and then you're answering some of the questions. Now, one more thing before I stop and let you calculate this is that some of these will end up being such low probabilities, like if I have a 72% chance of killing a tree. We just said this. Let me get rid of some of this junk over here. Let me erase some of this stuff. Well, I want to leave that. If I have a 72% chance of killing trees, okay, what's the chances that all 10 of them are going to live out of 10, right? If I have a 72% chance of killing a tree, this is going to be a very, very, very low percentage. Like it might be like 0.000000000, right? So if it is more than like 4 decimal places, go ahead and just list it as 0 plus, which means it's really, really, really close to 0, but it's not 0 exactly. So you have to make sure you put the plus sign on it. So 0 plus is anything more than like 4 decimal places that are zeros, right? Okay, if you want to go ahead and put those on there. Now, also, one more thing. If I have a 72% chance of killing a tree, which one of these combinations is going to have the highest percentage over here, right? 72% is going to be closest to, okay, die rate is 7, so it's going to be closest to this one. This is probably going to have the highest percentage here because that is the closest to a 72 die rate and a 28 live rate, right? 70% versus 30% is pretty close to 72-28 split. So this percentage is going to be the highest. That's going to happen the most frequently is 7 die and 3 live. Okay, because that's according to my rate. So that should kind of make sense, and you can go ahead and kind of use that same thought process when you're filling this table out. Okay, whatever these percentages are, make sure you check to see, like, does the highest percentage correspond here, right? Like, does it make sense that one of those would be higher than the others, right? Or like whichever combination is the highest, does it match with this split right here, okay? So go through and answer the questions, fill the table out. I think 31 is just answering the questions according to like what this table has, okay? Shouldn't take you very long, but go ahead and make sure you're typing these in correctly, the formula in. If you need to do it as 3 pieces, entering this one first, then this one first, then this one first, and then multiplying all 3 of them together, you can do it that way, whatever. But 10C5, that is in your calculator. Some of you guys need to go to like the PRB button. If you have a TI-30X calculator, you need to go to the PRB button and then go over to NCR. And you can type in your 10 and your 5. I think you have to type 10 in first. Type 10 in first and then go to the PRB button to find that C value. If you have a really fancy calculator, go to the math button and go over to probability. I think you go over like 3 spaces to probability and go down, and it'll have your NCR and NPR. Okay, so help each other find that. If you can't find it on your calculator, somebody probably knows, or Google is my friend, or I like go into YouTube and I say, where is my button at? And then it will tell you. Okay, so use your resources. There you go. I think that is all that I have for you. Okay, make sure you're using these columns over here to figure out how many people are spring babies. It wouldn't be a bad idea for you to check your answer, at least your percentage that you got to begin with somebody near you, just because if you get the wrong percentage to begin with, you're gonna, like, the whole table is gonna be screwed up. So make sure that you're checking somebody here and that you do have the correct number that were born in spring. Okay, March 21st through June 20th, that is going to be the spring numbers. Okay, so like this one is not a spring. March 21st, nope, not a spring. Not a spring. Not a spring. Through June 20th. Hey, there we go. Who is spring? Emma. Emma's our first spring baby. Okay, so that would count. So however many people there are out of 14, figure out what that is and put that percentage here for spring babies. Okay, there you go. That's all I have.